So in this video, we're going to talk about stack. So stack is a linear data structure that follows the LIFO principle or the last in first out principle. So we can consider the stack as a container. Now inside the container, we can insert elements from only one direction, from the top of the container. Now inside the container, we can put items like, first of all, let's just put the item 1. Then we can add another item, so we have to put on top of the previous item. So this way we can put item 3, item 4 and so on. Now if we wanted to remove the item, we have to remove the items from the top only. That means, so first of all we can remove the item 4, then the item 3, and this way we can remove one by one from the top of that container. So adding item to the container is known as the push operation, and whenever we remove the items, this is known as the pop operation. And also the stack or the container has some fixed capacity. So once it reaches its limit, no more elements can be inserted. So you can see the stack is filled. Now if we wanted to insert another item 5, we cannot do that. And this condition is known as stack overflow. So that is the basic principle of the stack. We can push items from the top, and also we can remove the items from the top only. And the last item that we push into the stack will be the first item to be removed out of the stack. So the stack can be defined as an abstract data type or ADT. Now that means it has a set of operations that define its behavior regardless of how it is implemented. So the operations can be, so first of all we have the push operation. So the push operation is used to add elements to the top of the stack. So here we can push elements to the top of the stack. Secondly, we have the pop operation. So the pop operation is used to remove elements from the top. So here we can remove the elements from the top only. So thirdly, we have the pick operation. So the pick operation will return element from the top without removing it. Fourthly, we have the isEmpty operation. So it is used to check whether the stack empty or not. And lastly, we have the isFull operation. It is used to check whether stack is full or not. So these are the operations that we can perform on our stack. Now the question is, why should we learn about the stack? Because stack is a fundamental data structure which is used in the computer science to simplify certain operations and provide efficient ways to manage the data. So like an example, first of all, it provides a structured way to store or retrieve the elements. Like an example, here we can store the items from the top of the stack only, and if we wanted to remove the item from the stack, we have to do this from the top of the stack only. And also there are certain problems that can be efficiently solved using the stack only. So let's now talk about some of the important stack application. So first of all, stack can be used to manage the function calls. So like an example, suppose we have a function. Now inside the function calls itself. So it takes a parameter and calls the function itself recursively with the n-1. Now to track this recursive function call, we should use one stack. Suppose we call the function with the parameter 4. First of all, the function call and all of its details will be pushed into the stack. That means the func with the parameter 4 will be pushed into our stack, and then it will call itself with the parameter n-1. That means the function call func3 will be pushed into the stack. This way each iterative function call will be pushed on top of the stack. So here we can have the base case. When the n is 0, then we can return. So here until it reaches the base case, all the function calls will be pushed on top of each other. whenever a function execution completes, that function call will be removed from the top of the stack. So first of all, this func1 will be executed, so it will be removed out of the stack. And after that, the func2 will be executed, then the func2 will also be removed from the top of the stack. So this way, the stack can be the best choice to track the function calls one after another. So the stack will ensure that the last function that is called is the first one to complete the execution. And also, stack can be used for infix to postfix conversion. So like an example, suppose we have one infix notation 2 plus 3 times 4. Now to convert this infix to postfix, we can use stack. So we can use the stack and it will be converted to the postfix. That means the operators will be rearranged after the operand. So you can see after the conversion, the operators will be rearranged after the operands, and which is possible with the help of a stack. And also we can use the stack for parenthesis matching. So here the stack will help in checking if a mathematical expression has properly matched parentheses or not. Like an example, suppose we have the expression a plus b times c plus d. So here you can see all the parentheses are matched. Now suppose in a case one parenthesis is missing. Now to check whether the expression has matching parentheses or not, we can check this with the help of one stack. So a stack will help us identify this missing parentheses. So these are all the important applications that we can perform using the stack. Now to implement the stack, there are two ways we can do that. Either we can use one array to implement the stack, or we can use one linked list to implement the stack. So in the next video, we're going to talk about how we can implement the stack using the array and the linked list. So hope you understand about stack data structure. See you in the next one. Take care.